Welcome to Learning Math in Easy English with Sergeant Hiromatsu. So today's lesson is about integer exponents and nth roots. So we have two goals for today. One is understanding integer exponents. For example, what does it mean if the exponent is 0 or a negative number? The second goal is understanding nth roots. We will learn how to use these new symbols. First, let's check how to read exponents. This is read 3 squared. This is read 2 cubed. This is read 5 to the 4th, or 5 to the 4th power. This is read a to the nth, or a to the nth power, or a to the power of n, etc. There are also other ways to read these, but these are the most common ways. Also, the numbers here, 3, 2, 5, a, are called the base, and the small numbers, 2, 3, 4, and n, are called the exponent. We know how to calculate these numbers. 2 to the first power is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4th power is 16, etc. So if the exponent increases by 1, then we should multiply by 2. Conversely, if the exponent decreases by 1, we should divide by 2. So if we follow this rule, 2 to the power of 0 should be 1, and 2 to the negative 1 should be 1/2, and 2 to the negative 2 should be 1 over 4, and so on. In general, given a is not equal to 0, and n is an integer, then a to the 0th power is 1, and a to the negative nth power is 1 over a to the nth power. In particular, a to the negative 1 is 1 over a, the inverse of a. In Japanese, we say a no gyakusu, and a over b to the negative 1 is b over a, which is just the inverse, gyakusu, of a over b. So for example, 5 to the 0 is 1, not 0. Also, 2 to the negative 3 is 1 over 2 cubed, which is 1 over 8. 3 over 2 to the negative 3 is 3 over 2 to the negative 1 to the 3rd, which equals 3 over 2. Take the inverse. 3 over 2 to the 3rd, which is 8 over 27. The point is, if the exponent is negative, you just need to take the inverse of the base. The rules for using exponents with integers is very similar to with natural numbers. Number 1 is a to the m times a to the n equals a to the m plus n. For example, a to the negative 3 times a squared equals a to the negative 3 plus 2, which equals a to the negative 1. With division, a to the m divided by a to the n equals a to the m times a to the negative n, which equals a to the m minus n. For example, a to the 5th divided by a to the negative 3 equals a to the 5 minus negative 3, which equals a to the 8th. So if you multiply two powers, you should add the exponents. If you divide two powers, you should subtract the exponents. Number 2, a to the mth power all to the nth power is a to the m times nth power. For example, a to the negative 2 to the 3rd power is a to the negative 2 times 3, which equals a to the negative 6. So with powers of powers, you should multiply the exponents. Number 3, ab to the nth power is a to the n times b to the n. For example, ab to the 10th equals a to the 10th times b to the 10th. Also, fractions are the same. A over b to the nth power is a to the nth divided by b to the nth. For example, a over b to the 4th power is a to the 4th over b to the 4th. Next, we will learn about nth roots. If x to the nth power equals a, then we say x is an nth root of a. This symbol is read the nth root of a, and it symbolizes the positive nth root of a. For example, 2 to the 4th power is 16. Also, negative 2 to the fourth power is 16. Therefore, 2 and negative 2 are the fourth roots of 16. So using the symbol for roots, we can write the fourth root of 16 is 2. Also, let's consider the fifth root of 243. 243 is 3 to the fifth power, so the fifth root is 3. Note, for second roots, we usually don't write the 2, and we call it the square root. For third roots, we call it the cube root. So let's check the rules for nth roots. Number 1, the product of nth roots is the nth root of the product. So you can separate or combine products of nth roots. For example, the cube root of 4 times the cube root of 2 is the cube root of 8, which is 2. Number 2, the same is true for division. You can separate or combine nth roots. So the fourth root of 15 divided by the fourth root of 3 is the fourth root of 15 divided by 3, which is just the fourth root of 5. Number 3, you can change the order of powers and roots. So for example, the cube root of 9, all squared, is the same as the cube root of 9 squared, which is the cube root of 81. But we can actually separate this into the cube root of 27 and the cube root of 3. And the cube root of 27 is 3, so we can write this as 3 times the cube root of 3. Number 4, the mth root of the nth root of a is the m times nth root of a. This is similar to Rule 3 for exponents. For example, the square root of the cube root of 2 is the sixth root of 2. Number 5, if we have the mth root of a to the nth, we can multiply both m and m by the same number. Of course, this means we can divide both m and n by the same number. For example, look at the sixth root of 8. We can write it like so. Then we divide here and here both by 3 to get the second root of 2, which is the square root of 2. Okay, well, I hope you could understand about integer exponents and nth roots. Thanks for listening.